bright future. Every student matters.
Fractions on a number line. Then you will also learn about proper fractions, improper fractions, and mixed fractions. So this is all what we are going to cover in this lesson. Okay. So here, let us start with this image. I hope you have a good idea what and how you represent numbers on a number line, right? So what you see in the first image here, you see that here the image shows 0 on the extreme left and 1 on the extreme right side. Is that right? Now imagine, say if this is a number line, okay? And if I'm starting from 0, I have 1, 2, 3, 4, 5, 6, and so on. So we can just keep on writing the numbers on a number line. Here we are just considering this part here, just this much, from 0 to 1. And what we just observed is that in between 0 and 1, we can have half, exactly sitting in the halfway. So this particular distance between 0 and half and this particular distance between half and 1, they are equal. So exactly if you divide the particular length that you have on the number line from 0 to 1 exactly into half, you write it as 1 over 2. So how many total divisions do you see from 0 to 1? We see total 2 divisions. Let's clear this all and let's see it again. Now look again, between 0 and 1, how many total divisions do we see? We see 1 and 2. So we write 2 as the denominator. I hope you remember what is numerator and what is denominator, right? Now look at the next number line here. Now what have we done? In the first one, we divided from 0 to 1 into 2 equal parts. Now we are dividing into 4 equal parts. See, 1, 2, 3 and 4. We see 4 equal parts. So look, 1 over 4, 2 over 4, 3 over 4, and what do you think will come next? It will be 4 over 4. And if I write 4 over 4, if I'm dividing 4 by 4, answer is 1. So am I right to say this? Or if you say 0 over 4, this is also equal to 0. So it is basically you are writing the numbers between 0 to 1, dividing them into 4 equal parts, and you are representing the denominator as 4. Okay, so it can be 0 over 4, 1 over 4, 2 over 4, 3 over 4 and 4 over 4, where 0 over 4 is 0 and 4 over 4 is 1. Keep this in mind, it's very important and it's going to help us more in the lesson. So now look at the next one. Here, how many parts do you see? Here they have divided into 8 equal parts. So 8 equal parts you see here. So what do we have as the denominator? We have 8. How can we write this 0? We can write it as 0 over 8. And when we go till 7 over 8, the next number is 1. How can we write 1? We could have even written this as 8 over 8. And now one thing more I would like to tell you here is that it is not that after 1 you cannot write anything on the number line. If you want, you can extend the number line, and because 1 is basically 8 over 8. So the next number will be 9 over 8. The next number will be 10 over 8. The next number will be 11 over 8. So on you can move. Similarly, if you want to move on the left of this line, this is 0 over 8. So this side it will be minus 1 over 8, minus 2 over 8 and so on. So the number line goes on and on in both the directions. You just keep in your mind how many divisions do you want on your particular scale in between 0 and 1. I hope this makes some sense. This will make more sense. Let's try an example. Okay, it says mark half, 1/3, 1/4. I hope you remember how do we read the fractions. If it is 1 over 3, so we read it as 1 by 3, or we read it as 1/3. If it is 1 over 4, it is 1/4. So we just write or say these numbers such. And if it is 1 over 6, it's 1/6. If it is 1 over 8, it is 1/8. Is that right? So this is how we read these fractions. Now we are going to mark these fractions on different number lines. Let us start here. It says how we are going to draw. We are going to start by drawing a number line. Okay. We know that half is less than 1. See, in a number line, I hope you remember, if we go on the right side, we keep on increasing. If we go to the left, we decrease our value. So here, because 1 is sitting on the right side compared to half, so 1 is bigger. So it's clear that why half is less than 1. But this is also greater than 0. Is that right? Because 0 is sitting on the left side of half. So we have to divide the gap between the two equal parts and then mark the middle point as half. So what are they telling you? That if you want to mark 1 over 2 on a number line, you divide between 0 and 1 into two equal parts. I hope this makes sense. Now, let us see here. In this one, it says as the denominator is the whole and the numerator is a part. I hope this makes sense. You do remember that when we write a particular fraction, whatever we write on the top, it shows a part, and whatever we write at the bottom, it is basically a whole, right? So we have to divide the gap between 0 and 1 in the number of parts that we are as the denominator is given. So that many parts we need to have as the denominator. For say if you are making 1/3, how many parts do you need on your number line? On your number line, if this is 0, this is 1, you need to divide it into exactly 3 equal parts. So this will be 1 over 3, this will be 2 over 3, and this one is basically 3 over 3. Now if we are drawing 1 over 4, what do? We divide into 4 equal parts. So this is 1 part, 2, 3 and 4. And how do we mark? This is 0 over 4, 1 over 4, 2 over 4, 3 over 4, and if we want, we can write this as 4 over 4. Okay, I hope this is making more sense now. Now look at these number lines here. Look at the first number line. They have divided the number line into 8 equal parts. So each part representing 1 over 8. How many parts do you see till this region? If we reach at this point, how many parts do we see? We see 2 parts, right? So it is 2 over 8. If we are talking till here, from 0 till we reach this part, how many parts do you see in total? We see 6 parts. So it's denoting 6 over 8. Now look at this one, 1/3 one, this one, 1/3 one, right? So here, if I'm talking from here till I reach this particular point, so out of 3 blocks that I see, I want to know what is the fraction for these 2 blocks. So it is basically 2 over 3. I hope it's making more and more sense every time. Now let us see one example, and we are going to do this ourselves so that we are having a more clear idea in our head. It says show 3/5 on a number line. Okay, so it is 3 over 5. So in 3 over 5, which number do you see sitting at the denominator? At the denominator, we have got the number 5. So we can write it here. Denominator. And at the top, what do we have? It shows the part of the whole. We call it numerator. Right? So now what do we need to do? We need to represent this on a number line. So the first thing that we can do is we need to put a straight line here. A straight line on which we are going to mark certain numbers, right? So what numbers are we going to mark? Starting from 0 and here it's 1. Why are we putting 3 over 5 in between 0 and 1? If you can think about dividing 3 by 5, because if you write in a fraction and you think about dividing it, 3 will come here and here you will see a 5. And you can clearly see the answer that you will get. It will be somewhat in decimals, right? So basically 3 over 5 is smaller than 1. Like you know that half is smaller than 1, similarly 3 over 5 is also smaller than 1. So all what you can imagine is, where do you think 5 over 5 will stand? 5 over 5 will stand at 1. This is 5 over 5. Where do you see 0 is basically 0 over 5, right? Now, what number do we have as the denominator? We have got 5. So how many divisions do we need? On this line, we need 5 equal divisions, right? So let's do 5 divisions. 1, 2, 3, 4 and 5. If I'm not able to draw these divisions like very much equal in sizes, make sure that if you are drawing them, you measure the line and then you, using the ruler, the scale that you have, you measure these distance accurately and then you divide it into half, or in 3 parts, or in 4 parts, and here as it is required in 5 parts. Okay, now it says we need to show what is 3/5 on this number line. So how many parts are they asking us to show? 3 parts. So here this is 1, this is 2 and this is 3. So this particular mark here, this represents 3 over 5. I hope this makes sense how we have marked 3/5 on a number line. Now let us show 1 over 10, 0 over 10, 5 over 10 and 10 over 10 on a number line. Clearly keeping in our head, what number do we see at the denominator? That is what we are required to put as that is the number that is required to be seen in the number of divisions on the number line. So here clearly what we see, we have got 10. So we are going to make 10 divisions on the number line. Okay. So here again starting from 0. Why? Because clearly what we see that 1 over 10, 0 over 10, 5 over 10, they are all less than 1. And the last number which is given, that is 10 over 10, is nothing else but 1. A number divided by itself gives the answer as 1. So instead of 1, let us write 10 over 10. Okay. Now let's divide this into 10 equal parts. I'm sorry if I'm not able to divide it accurately on the parts. Make sure that you do it by measuring, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So we have roughly divided this line into 10 equal parts and let us mark all the points. Here it says 1 over 10. So where do you see 1 over 10 in your line? It is here. 1 over 10. Where do we have 5 over 10? This is 1, this is 2, 3, 4 and this one exactly in the middle is 5 over 10. Okay. Now where do you see 0 over 10? It's 0 over 10 because 0 over 10 is basically 0. I hope you are clear how we have marked all these points on the number line. Moving ahead to the next question. It says, can you show any other fraction between 0 and 1? Do you think it's possible to show any other fraction on the number line starting from 0? And we are just considering till it's 1. So if you think that you can only put 0 and half or 1/3 or 1/4 or 1/5 on the number line, no. We can basically put infinite many fractions on a number line. Okay, so it's just how small your division needs to be, and infinite many divisions can be made in between 0 and 1. Okay, because this number 1, it can be anything. It can be literally anything. This can be 1,000 over 1,000, but this is still 1, right? It can be a crore over 1 crore, it'll still be 1. I hope this is making sense. So we can basically make as many as divisions as much as possible. We just need to be sure that we are making all the divisions of equal length. Okay, so it says that can you show any other fraction? Let's just show them any simple one which we can make here. So I'll just erase them. Okay, so say here instead of 1000 over 1000, let's say we have got 6 over 6. So this basically 1 is representing 6 over 6. So how many divisions do you think we need to make? 1, 2, 3, 4, 5 and 6 divisions, right? And let's show these fractions. So this is 1 over 6, this is 2 over 6, 3 over 6, 4 over 6, 5 over 6 and 6 over 6. I hope this is clear. Now the next question says how many fractions lie between 0 and 1? Oh, we have just discussed about this answer. How many fractions lie between 0 and 1? The answer is infinite. How many fractions? Infinite fractions are possible between 0 and 1. Moving ahead, now let us talk about proper fractions. I hope you have got a clear idea how we are representing these numbers on a number line. So we are moving ahead with the proper fractions. Now as the name says, it needs to be proper. Okay. If the numerator is less than the denominator, it is called a proper fraction. Read it again. If the numerator is less than the denominator, then it is called a proper fraction. This is a simple definition. Look at the examples in front of you. It says if we represent a proper fraction on a number line, then it will always be between 0 and 1. I hope you remember what we discussed about this. Because 1 is basically what? A number divided by itself. So every number you see, if it is like having any number which is smaller than the denominator, it will be always less than 1. For example, 5 over 7. Let's say 5 over 7. It is smaller than 1. Why? Because 1 is basically 7 over 7. This is 1. And we can clearly see 5 over 7 is smaller than, it is smaller than 7 over 7. So this is smaller than 1. Similarly, see 3 over 10. So 3 over 10 is smaller than 10 over 10. So this is lying on the left side on the number line. If you imagine, this will lie on the left side of 1. So it is smaller than 1. Similarly, if you have 2 over 3, it is also less than 3 over 3. If you see 4 over 9, it is less than 9 over 9. Clearly keep this in your head that every proper fraction will have smaller number on the top and it will have a bigger number at the bottom. How you can imagine this is, for example, see, if I keep this smaller box and on the top of it I keep this bigger box, do you think this structure is stable? Or say if on this box I keep this small box, which structure do you think is stable? Think as like any small box you are keeping, or this can be a small stone. On this we have got a bigger stone. This first image, it is very prone to fall down, right? But the second one, it's very stable. So this is how you can remember that which structure do you think is looking more proper to you? I think the second one. So this is how we are going to remember the proper fraction, that is on the numerator we see the smaller one and on the denominator we see the bigger one. Okay. So all these fractions that you see, they lie on the left of 1 as they are all less than 1. I hope this makes sense.